It's me again, Nada Saab. I'm trying today to discuss with you how to take advantage of the PhET simulation and understand the frictional force. So it's really very good simulation, and let me tell you exactly how to go to this. So you Google it here. So you set PhET simulation, and it is here. And then you click on that, and then when you're here, you scroll down and get physics, and then let's just narrow the search a little bit by unchecking all those boxes, and then keep only motion, and then you'll have forces and motion basics. So we're going to be working on that. Click on this. Okay, let it play. Okay, I'm gonna skip all these with you and then go to acceleration, and then we're here. Okay, what I like the most about this simulation, it does show exactly like the frictional force in everything related to that, like all the forces acting on an object. So let's go ahead and check all those boxes here to be able to see everything in all the values, and then let me review with you a little bit the important forces that may act on an object sitting on a flat surface like that. Okay, so let me see, I get this one. First of all, those are the important forces that we usually present. One of them is the way equal mass times acceleration. And then how it is, it's usually from the center of mass down the direction 90 degrees to Earth. And then when you have two surfaces on contact, then you have the normal force. The normal force is usually also called the support force. The direction is up, opposite to way, and 90 degrees to the surface of contact. Then you have the frictional force. We have two types. You have the static frictional force, and then you have the kinetic. A static means when the object is at rest, and then kinetic means when the object is moving. And then this is the formula. Usually the frictional force or force of friction equal the kinetic of coefficient friction, the kinetic here, if we are talking about the kinetic times the normal force. What is the direction? It's usually parallel to the surface of contact and opposite to motion. The tension force is usually it's usually when you have a rope, opposite direction of the rope, start at the point of attachment and then away from the attached mass. We are going to focus today on these three ways: normal force, friction force, frictional, or the force of friction. Okay, let me go back here. I want you to notice something. I want you to notice here that the people who really did this simulation, they did a very good job. This is a friction. So a friction is usually the surface, the force that holds the two surfaces on the top of each other. They did one of this before in a previous, like something like this, also a PhET simulation. This is a physics book and this is a chemistry book. If you put the physics books on the top of the chemistry book like that. So the force of friction is the force that exists between the particles here holding these two books on the top of each other. And then if these two books are not moving, so it's a static friction, right? And then when they move like this, then it's kinetic. Fun, okay. Now the more particles you have here, if I do this for example, the more particles you have that are holding each other, the bigger the frictional force, or the rougher the surface, if you want to say. Let's go back here. Okay, so notice here what they did. If you have no friction at all, that means the surface is very slippery. If you take this all the way here, look what I do here. See, all the way it becomes icy. Okay, which means it's very slippery. There is no there is no friction. The static friction is almost nothing. It's very simple. So any force you put on this box is gonna move it. Look, see, look at the speed here. Even 2 newtons is all applied to be like the sum of force. There's no force of friction at all. And then let's go back here. Okay, so notice again that if I increase the friction, then notice what happened. They start putting like brown stuff here to show you that the surface is getting rough. The more you increase the friction, see that's rougher and rougher. See, look at that. The more friction you have, like the harder it is to push this box because the surface under it is rough, right? Okay. So anyway, if we need to represent the forces acting on this box, we can show them by the following here. Okay,